Good morning. Today is Saturday at beautiful city of Diamond, California. My name is Wahid Lutfi. I'm going to compare or compare and contrast between Windows operating system and Linux operating system. I'm not going to distinguish the differences in terms of which one is better, but I'm going to just show similarities and also some of the commands that are working on one versus the other one and how they work, how efficient they are, and all that information. So you learn both operating system in one video, both Windows operating system as well as Linux. In this case, Linux Ubuntu. I'm going to compare and contrast basically. Okay. So now I have shared my screen. You can see, and there are two terminals or console that I open. In this case, the terminal on the blue color is the Windows 10 operating system, as you can see here, that Microsoft version 10, Microsoft version 10 of Windows operating system is running, and this is the built version. So this is just basically whenever you open a command prompt, it tells you that you're running Microsoft version 10. So if I just look at that one information and then compare that one with Unix, uname-a will just tell me the details of similar information saying that I'm running Linux operating system. This is the node name, this is the built version, and then the symmetric multiprocessing version of it, and the built date, and then all the x86 and the rest of the information. So now I'm going to just go on the Windows and I type in CMD. As you can see, every time I type in CMD, a new terminal command prompt opens and it tells me that I'm on Microsoft version Windows 10. So if I exit one of them, it opens it. And if I exit the second one, I'm back to my main command prompt. Here I can do a uname and dash n for the node name, uname dash s for the kernel name, uname dash o for the operating system name, uname dash o, I just mistyped it. So clearing the screen, uname and dash o, and you can see that is the case. Uname and dash kernel name is similar to uname dash s. Now I'm going to clear my screen on Windows CLS, and then I do the same thing on Linux using clear command. And so that is how you could do both of them on the one shot. Here I'm going to do a system info and then pipe more so I could get all the information on Windows operating system. And you can see that this is running for a little bit, and it is going to tell me that I'm running Microsoft Windows 10. And then it tells me about the CPU, the memory, the how much RAM I have, and how much what type of CPU I have. Everything details are there. As a matter of fact, if I just clear a screen and then run the same command, and instead of that one, I just say OS name, just like that, and I get the operating system information. Similarly here, uname dash n was giving me the dash o was giving me the operating system, as well as uname and dash r gave me the revision or the build, and uname dash p for platform, uname dash m for the machine type. So you can get that information similar to the system information. If I just clear my screen again and I say cat minus n etc os dash release minus n, so I can see the line number. As you can see on line 5, it tells me that I have Ubuntu 20.04.4 long-term support. And then that's the details of the operating system on Linux. Thanks for watching. Now I'm going to show you how to get the system information related to your CPU. Find /i, and then you can search for a word like CPU, and then that would just reveal the Windows operating system version of CPU if it is there. So in this case, let's just look for the string model. If the string CPU is not listed, maybe the model is going to show. Yeah, it does show, and then it's AMD. So I could have just done the same thing with AMD if I knew the processor AMD, but the model word is there. So similarly, if I just go here and I say cat/proc/CPU info, and then grep -i for model, then I can just get that information about the CPU model. And if I just want to clear a screen again here, and then instead of this grep -i, I could do egrep, which is extended grep, global expression, regular expression print statement. That's what egrep stands for, extended global regular expression print. So I could say for model, and then I could also say, for example, on the megahertz. Since I did not just use the option of, since I did not choose the option of uppercase, I just did that one. So it is showing the megahertz also and the speed of it. Thanks for watching again. Okay, now we're going to compare the memory commands on Windows versus Linux. So on Windows, if you run system info pipe find /i, I meaning ignore the memory, ignore the string memory in uppercase or lowercase, it will show you the memory that you want. Similarly, on Unix, if you just do this command saying cat/proc/meminfo, this is the proc file system, which is a pseudo file system. The actual file size is 0 because it's reading from memory. And then the extended grep command that we are doing, egrep, it's going to search for matching to string in lowercase or uppercase, doesn't matter. And then you can see the memory total, and then the direct information is shown here. Thanks for watching. Now we're on Windows and we want to just get system information. Overall, what is the resources that we have in terms of memory, CPU, and everything else. So right now you can see the operating system is Windows 10, and I'm just having that pipe more so I can see one screen at a time. Similarly, if I just want to say this one, cat etc os-release, this information is revealing the operating system, as well as I can say cat /proc/meminfo for memory information. You can see the entire memory information here, as well as cat, let me clear the screen here, cat proc/CPU info. And then CPU information is also revealed here. So we compared the memory as well as CPU in both operating system, and we looked at the version of them. Again, thanks for watching. Okay, now we're going to compare the ping command and the traceroute command or traceroute command between Windows and Linux. So when I do a ping google.com, this is going to just ping google.com, and then I can also do a trace route command on google.com. On Windows and on Windows is traceroute. On Linux it's traceroute. So this is the difference between the two. On Windows you type in traceroute, and on Linux you type in traceroute. So if I do a ping google.com here on this one as well, and you can see that it is running. So I'm going to stop it here and clear my screen and say trace route actually on Linux. So google.com, and you can see that it is going to trace route on google.com. If you want it to be faster, you have to do it on the www.google.com, because that one is basically resolving to the secure page right away as fast as it is possible. And then here, similarly, you do www.google.com, and that would resolve it a little bit faster than the other one. As you can see, the Linux is already done, and Windows will be done as well. So, and the difference between the www.google.com and google.com, google.com is going to actually redirect to www.google.com, but they are both redirecting to HTTPS. So that's how you know that when it is resolving HTTPS www.google.com, it will be faster in that case, because it doesn't have to redirect without the www, it is just redirecting. Thanks for watching. On this one, I'm going to show you on Windows, if you do ns lookup, for example, for google.com, you can get the A record, which you can also do a minus Q for query is A for A record, and then type in google.com here. Similarly, if you want the MX record, which is mail exchanger record for google.com, and then you can get that information as well. And then clear my screen here. I'm going to do clear screen here and say ns lookup. If I don't provide any information, it's giving me kind of an interactive thing. So I could type in amazon.com, and then oracle.com, MyWebUniversity, MyWebUniversity.com. Any web server that you do, you just basically get their information. So on the Linux, similarly, NX lookup, if I just don't give anything, I could say oracle.com, and then google.com. You could just get it and then type in exit, clear my screen here, and I say ns lookup minus q is equal mx, and then google.com. You can see minus q is equal mx google.com. It does show actually for google.com symmetric multi simple message transfer protocol, or well, here you can also do for the Yahoo, for example, for the MX record, and then the mail exchanger record is going to show. So clearing both the screen here, and thanks for watching again. In this session, we're going to show you how to do a Windows operating system and Linux operating system, some of the comparison between a task manager and a command like tops and other ones. So let's open a task manager first here by right-clicking and choosing task manager. And when task manager opens on the top here, this white window that you can see as task manager here, I'm on the processes, and then basically, and the processes are showing on the list of the process. These are running processes that are currently there, and there's background processes. Equivalent to that one on Linux, you can run the command top or htop. If you type in clear screen here, and you have the GUI version of it, it's htop. But I'm going to show you the regular one for top here, because this one has all the information we need in order to make this video for comparison of Windows and Linux. So as you can see under the process for the task manager on the Windows side, you can have all these 7 apps that are currently running. And one of them is my command prompt that we were just practicing here. So as you can see that this is the window. If I just close this command prompt here, you notice that this is going to go away. And if I just open another one here on the command prompt, as soon as I open it, this one just shows up here. And then when I close it again, watch, when I close it, this window, it's going to disappear. I can also have control over it by just typing in CMD here. And rather than exit here, I can just right click here and say end task, and that will close it as well. That's why this task manager is very useful. You have also a button, a tab that says the performance. So you can compare the performance of the CPU and other system. Later on, I'm going to check on the Linux side because we cannot jump back and forth. It's too much here, but I will show you the differences between them on this video. So now you can see the performance on the CPU usage, you can see here. And then obviously here, I mentioned that I'm not gonna jump back and forth, but I just did. So you can see here the CPU usage is also showing for the user level, for the system, for the nice, for the idle, for the wait and everything else. So let's just look at the memory usage. The memory usage, you can see here that it tells you the memory usage and how much is on Windows side. In this column here on the top, it will tell you the memory usage in terms of how much is total, how much is free, how much is buffered, how much is in the cache, and how much is even swap space. And then that information is shown here. So and then this is page pool. It's basically the swap on Windows. So right here, if I look at the hard disk drive here, this information is not doing it because on Windows and on Linux, you have other command like vmstat is for virtual memory, iostat, and so on. So I'm going to run back top here to show you that we have a lot of commands. You don't have to rely on one one task manager kind of window. But the nice thing about Windows is once you open this interface, it has a lot of more functionality in terms of the GUI rich interface that you can click a button and get that Ethernet information. You can get the GPU information, all of that one is there. And then at the same time, the app history. So like if there's any apps that are installed and everything that is on the CPU usage, you could do that one. Here, because I'm on Linux Ubuntu version 20, long-term support, I can do a app list. And this would just list all the apps that are installed on the Linux machine. So you can see how fast that was. And you could do a word count -L, and then you can get a list of, it's about 81,000 apps that is installed on the system. So now let's look at the start up script. The start up script is or processes that you want to started on the system when your system starts. And if you don't want Cortana to be there, then you have an option of disabling it or enabling it. Similarly, for any other process, like here, Microsoft Team, if I just want to enable it, I could have it. But depend on how fast you want your system to start. Linux, when it starts, all the files that are on the startup script, which is normally on Linux under etc or C 3.d in this case, or etc and net.d. And those ones will be just spawn off based on the whether they have a S in front of the etc or C 3.d, like S star. Those names that start with S, and it is going to just start it. And if it has a kill in front of it with K, then it will just say shut down that process there. So normally also you have init levels, and then etc or C (d). You can see this is a list of them, and if I just do with the -D, you can see that they're 0 through 6, and then the run level S for single user mode. So 0 is the shutdown, and then 1 is when you do administrator level. Run level 2 is for a multi-user run level. Run level 3 is for multi-user with NFS mounted. And then run level 4 is not used. Run level 5 is for graphical user interface on Linux. And then run level 6 is the reboot or power down. Run level 6 is also on Solaris. Is you can shut down if your system is having the button to just power off when you do a net level 5, and net level 0 and just power off by itself. So you can do those commands as well. Let's look at the users. The users here is there, and then you can also type in on the Unix users, and then the list of the users and the get end password. This would just give you all the users that are on the system. Get end password wlitfi will give you specific to the user. ID and dash UN would give me my user ID and name. ID dash and just N and number. So ID dash UN would give me that one, and then GN would be for the group name, and ID by itself will give me the numbers total of all the information there. So the details of here, this is more detail level information for each of those processes that are running, whether the status is running or what is the process ID of those ones. And you can check on the process ID here on the clear. If you look at the top here, you can see the process ID of each of these processes that are there. So like wlitfi, the process ID is there, the root is 1, and then some of them. So if I just clear the screen, say top minus u wlitfi, this would just only show my process ID for user Lutfi. And then you can see the process ID for each one of them. And then you can also do a clear screen ps minus EFA, 5 more, and then you get the process ID of all of that. If you do a ps minus EF and then awk and then say print $2, this would give you the process ID of all of those users. And then as you can see from this command, we have the user on the process ID 1, and then second one was this. So I could have just done this and say print $1, $1, and then $2. This would give me that, but I wanted a space in between them. I could put a space in between them, and then that would just show the process ID of those ones. So the command would be just like this. PS minus EFA awk print $1 space $2, and it's there. If I just did this one and then I did not put a this, I put a comma here, that would be equivalent to the same information. So I didn't have to separate it by the code here. But if I want to just put an equal sign rather than say something like that, then I need that between the code. So like this, you can see that is a root, and then the process ID of it is there. So you can do a lot of stuff with these commands. Under the services, like what services are running, or what services are started here. On the Linux also, you have a number of daemons that are running on the services. For example, clear screen, if you say lsof minus I and then colon port 22, then it will just say port 22 if it is running. So now I need sudo in front of it, because that command requires a root privilege. So then I run that command and it will show that one. I could also do a netstat minus an and minus an and grep minus I for the word lesson. So anything that I'm listening, I'm going to look at them here. And then 5 more is there. So if I just do similar command and then just say, let's say grep minus W for port 22, then I could just say, okay, any word that are separated just for the word 22, that's the LSOF or port 22. I could also do a netstat minus P for protocol and then type in TCP here. So clear screen, if I just do the same thing and then just say colon 22, then I could get the colon 22, port 22. If I just wanted my Apache server, I could just say ps -ef grep -I http. This would just show me my Apache processes. Similarly, if I could say minus, let's say grep -w port 80, that's also port 80 is not showing, but I could just do a clear screen here, ps -ef grep -I my Apache. Let's say I get that one, and then I could say netstat -p and then colon 80 port 80. That would just reveal the same thing as lsof port 80. So if I just say lsof -I and then port 80, and then I remember this one required root privilege, so sudo in front of it, and then that would give me the MyWebUniversity Apache web server. If I just did that one and just replace that one with netstat -p, and then that port, it will just give you that port 80. And then if I just do another grep -I for MyWebUniversity, let's say my web, and that would just say that, yeah, MyWebUniversity.com is listening to the connection is established, this one. So that is about it for the both of the comparison of those two. I'm gonna run top here and leave it running, and then thanks for watching. I appreciate it. Hi. On the blue screen, you can see that I'm the terminal. I'm just logged on as administrator command prompt. So I'm going to run the WINS assessment tool with argument of CPU, and then pipe more. So this is just WINS. I forgot the S here. You just have to type in WINS assessment tool, CPU, and then pipe more. So that would just give you the Windows assessment tool information. Let me clear my screen again here. I'm going to just run the Windows assessment tool with the CPU and pipe more. This is going to give me everything about the CPU information that is there. Similarly, if I want to do the memory assessment tool, you can do memory and then pipe more also. If there's more details on it, you could just get that information on this. While this one is running, I'm going to run similar command on the Linux side. So cat -p, not cat -n /proc/meminfo for the memory information, and then clear my screen again. And instead of meminfo, I could do CPU info. So that would just reveal all the information about that. I could also do ls CPU for CPU information, and there. On the Windows administrative command prompt, I'm going to type in wins AT for Windows 8 assessment tool -v, and then CPU, and then pipe more. So this will give me all the information related to the CPU for my Windows command prompt, from the Windows command prompt. Similarly, I can do ls CPU here, and then clear the screen, ls CPU, pipe more. I can get all the details of the processor's speed and how fast it is, and what type of processor I have. And I can also do a cat/proc CPU info that is giving me similar information there. So you can run these commands to get your system information in terms of the processor speed and everything else that you need on Linux as well. Thanks for watching. On Windows operating system, if you want to just do a directory command, basically it shows you what are your directories. You can also type in directory followed by the directory name and get the listing of it. So if you do a directory simply without any argument, you can get that one. So similarly, you can do a directory /o:\d, meaning that option in descending order. So you can see the latest file at the bottom of the file that is there. So whenever you do that one, you will see it. On Windows, on Linux, you can type in pwd, print working directory of executable. If you didn't set your environment PS1 to just be pointing to the /w, which is pointing to the home directory. And then you can just type in pwd and get that information. ls-ltr will just show you all the files similar to the /o:\d in descending order, the latest files that are there. So I'm going to do ls by itself. You could see the list of files here. Without any argument, you will see the type of the files that are there. And then you can do ls-l pipe more. You can see that the long listing of the files, you can get it. ls-cf, for example, give you the in column-wise information. So there's a lot of parameters that you can do on this. And ls-ltr pipe more is very useful because it's similar to the command we did here for it. And now obviously, like here on Linux, you can just say clear screen and then say ls. And let's say if I just want to know a directory like backup, I can do on the backup here. So if I just want to know something like ls-ltr backup, obviously that one only has one file, but it's going to list those ones. Similarly, if I say ls-ltr star.sh, I can get the files, but notice the LTR, and these files are the last files that were created. So they have a timestamp of it as well. Thanks for watching. In this session, I'm going to show you the comparison of the command tree between Windows and between Linux operating systems. So in this case, I'm already on Windows on the blue terminal session. So you can see I type in dir and I got the listing. So if I do a tree without any argument, it's going to just run these commands for all of those directory. I'm going to Control-C out of it, clear the screen again and do a dir. But this time I'm going to be more specific to the public directory. And then I could see that one. If I just want it in full, I could see the files as well as the ASCII part of it. Similarly, if I just do dir here, I do the other directory that is Wahid, which is larger. I could do a dir/Wahid here. And then that would be just running this one for a long time. But I'm going to clear screen and run this one with /f/a for ascending order. And then that would run for a while. But at the same time, I'm already on Linux, clear the screen, pwd, ls, these are the files. So clear the screen now again, do a tree command on the C++. You can see, get it, that information. Similarly, I can do a clear the screen again, and then do a tree on the Python. So you can see the list of the directories and files in full. If you want just to be specific to a particular directory like /lib, that is right here, you can see /lib is huge, right? So if I just do a word count -l, and I want to do a /lib here, the tree of it, sorry, the tree without the G here. And then you can see that it opens all the list of the files under it. It's 4,053 altogether. And then when I did the tree lib command here, this command, if I wanted to get that total here, I could have done that -lr, r meaning recursively. So the number is much larger because of on one I'm getting a long listing with recursively, and the other one I'm just running a tree command. So the tree command again is just tied to whatever modules and directories you're running it from, and in this case it is there. And if you could just say tree here, tree, and then on the shells, you can see that it is there. ls minus l. So the other one is still running. I'm going to stop it because it's a lot there. And then just running for a particular directory, you could run it faster, like 3 public /a/f, and then it will just be faster there. If I don't provide any argument, by default is in not in ASCII. So if I just wanted an ASCII format, it is a different format. Thank you for watching. Hi, in this session, I'm going to show you how to use the package name called tree, and then how to install it, how to uninstall it, everything. So let's just see that if this system already have a package called name, a utility name called tree. It is part of the Snap package manager. So in this case, I'm on a Linux machine, and I'm going to just say, let's look at the Snap list and then tree. So that will just list that this one is already installed. And as you can see, the version number and revision and all that tracking information. So you can also do a snap info tree, but this information is a lot more information in terms of getting the information in detail. So you need to just do a pipe more on this one to read one screen at a time, and then know what is this package. The snap a directory listing command that produce a depth and depth listing. Okay, so when you do a which tree, it says that it's installed, meaning that I'm on this current directory. If I do a tree command here, then I will get an output of all my directories and files from that one, which is very nice tools. In addition, I can clear a screen and do a ls and say, give me a tree of the C++ codes. You can see that is similarly. And if I do go give me a tree on the Python codes, excuse me, it will just give you the Python information there. So we know about the tree command, what it does. Let's see if we can just get some more information from Snap package manager. So Snap by itself is a package manager that's self-contained. So if I say snap dash dash help, it reveals a lot of commands that is there. And a couple of them I'm going to use here, say snap list tree that we already checked, and then snap info tree. This info tree is giving me the information that I just did earlier. I'm going to do snap. What else we could do? A search on the tree command. Notice this one is searching all the information that is pertaining the string or containing the string tree. In order for me to just do it only for the tree package or the utility, then I can do a grep command -w for a word, and then I could say that it starts with the word tree. That anchor that I put on the top of in front of that T for the tree, it will just give me only matching this. So this is a regular expression match string that I'm doing here. If I just want only to match the last character, I would do a regular expression with $sign. And then that would show anything that is with the $sign at the end of it there. So this time I'm going to clear the screen and say, okay, I have the snap, but let's see if I can do a snap remove on tree. So when I do that, when it says access denied, because my permission is not root. So I need to become root, and then I'm going to become root here. At this time, I'm going to also set my prompt to just show something more nicer here. So echo $sign prompt PS1 is pointing to that, and that is just no matter what directory I go, like if I go to home wlutfi, that is going to just show that the directory. When I cd to program files, is because of this host name information. All the details are this slash host. This u at is going to be root at. In this case, since I'm logged on as root at the host name. Host name is just that, and then this is the h, and then :/w. Colon is this, and then /w would be the home directory. And $sign prompt is normally the prompt, but because I'm root, it is pound. So I explained that one, but now let's just export PS1 and make it a shorter environment variable. Before I do that one, let me cd out few directory. So I'm on here, and then I just say export PS1 is equal. I'm gonna just say root, and then I could just say, well, however I want to write it, at Linux. So then put this pound in front of it, and then just give another space, and then that would clear the screen. And now I have my prompt there. So notice $PS1 is, excuse me, and $PS1 is pointing to the root at Linux one. Okay, so now I'm going to do the same thing, and this time I'm already root, clear the screen ID, and I'm going to just say snap list 3. I'm going to just try to remove that one as root. So I'm going to say snap remove and then 3. So the snap just removed it, and now if I say which which tree, this command is not found anymore. And if I say snap list 3, it is not there, no matching there. But if I just do a snap info 3, that is still telling me that, yeah, there's a package called 3, and if you want to install it like this, and then I could do my previous command grep minus w, and then start with the string 3, then close it, and then right here I could just get this information if that was on the, maybe it was on the search. Yeah, it was on the search. So you could just now say which 3 it is not installed. I'm going to say snap list 3, it says it's not installed. So I'm going to say snap install 3. This will just go into the snap package manager, and then go to the repository. It will find the package snap list again. Now it is installed, and then it says, okay, I found it, and it is there. File /snap/bin tree, and it is there. And then here I go back to my home directory wlutfi, and then say ls here, and then do a 3 on the C++ again. You can see that the command is running here, and go to programs because that was not the directory. So 3 C++, now it is showing there. And then similarly with Python, notice that the difference is that now it says error opening the file. So why is that error opening file? Because of something. So let me just see why it is not opening the file. So the files are there, clear screen, and then I say 3 Python. Maybe I mistyped it. Python error opening file 0 directory or files. So something is wrong here. Let's see 3 on the left directory. Yeah, 3 on the left directory is there, but maybe I blocked the permissions on that directory of Python. So let's look at it, see ls-ld Python. This is how you know what permission of that one. Yeah, this is not readable by other users. Even though a root should have full access to it, I'm not a root here in this case. If I see su-wlutfi, and I just go there to my programs, and then say 3 of C++, it will open it and clear a screen 3 of Python, it will open it. That's not a problem because the permissions on that directory, as you can see, clear screen ls-l, you can see that C++ is opened by W3 for readable, and then this is the permission of C++. This is a symbolic link to that one. Similarly with Python. So when I talk about permissions, I'm going to just cover up some more on it. But since we're in here, and I want to just show you on this directory, notice that ls-l, these files, for example, the C++ here, if I want to just have read executable permission, then I need to open it for the group as well. And I don't have to open it for the public, for everybody else. So I'm going to say change mode, and then I'm going to say 750, and then C++. So now if I do a 3 on the, look at this ls-ld, actually, I need to do it on C++ with this, because this is a symbolic link that is pointing to that one. So I need to do that one. And then now if I just clear my screen here, ls-ld, C++ and C++ like this, so you can see both of them. The one that are C++ is now open on this, which means that I can do a 3 on C++, and then it should be fine. It's still not there. Let's see if I need to open it further, because somehow it is not seeing the permission. So let me just say change mode 7. Actually, because I did not do it in recursively, so the directory itself is trying to open it, but it does not see the files. Since this C++ has a lot of files that are readable by root as well, but somehow Snap is not reading it. So let's see why that is the case. C++, I'm going to just open it up with this command, clear screen. I'm going to open it up, C++, everything here. I'm going to say change mode -R 755 C++, everything. So I could do everything with this, just to make sure that this is opening everything with read-write curl and everything else. And I could do the same thing with Python, and just to say include the Python also. Python, just to do that and those ones. So now if I just do ls-ld star those ones, not 755. So ls-ld, I need to just read my commands here. So that is the command. And if I just do now say 3 on the Python, for example, this is still not showing up. What is going on here? Which 3 snap, then 3 Python. Okay, so the parent directory might be locked there. So here, this is the important thing. When you look at the programs, if I did not open it for the programs here, you see that programs, this one, it is not open. So this is not open, and that is the problem. So I'm going to say change mode temporary 7 -R, and then I'm going to say 755, and then programs. So I'm going to just make everything readable and executable for those ones. Then the source code does not need to be done. I could just change those ones after. So let's just look at this. And then we did this. Now the program files are there, programs, and then I'm going to just say 3 on programs, and still not showing up. So the 3 is not showing up at this time. I ran out of the permission issues, but it says error opening dir. So let's see any other directory here that it is open from it. 3, yeah, I think it is just because of the /home wlitv. I don't want to open it too much because this one is wlitv. Yeah, see, that is because of this. So if I just make the parent directory of wlitv as root, and then it should be okay. Change group root wlitv. Now ld wlitv clear screen is root, and then now say 3 of wlitv, and we're opening a list minus l or wlitv. This one opens it, but 3 command is not. Maybe the 3 is somehow not having proper permission with that one in terms of a snap versus the apt-get, because these other package or apt packages. So if I just get out of this root here, and now I'm on my home directory, I can get 3 of all of them because of this information is okay, since the permissions I set it up originally there. And then I could do the same thing with 3 of C++, and then you will get that information. And if I go here, say 3 of programs, and like look at this one, pwd ls minus ld programs. So it's all there, and then I can run the programs here. I'm going to change the permissions afterward also, but the way this programs and the way these are, or you have to just say, well, if it's a text file, don't change the permission to 755. For example, let me just show you what I mean here. If I just clear my screen, say find dot minus name star dot text minus dot text, and then say minus exact, and then here I could say minus exact, and then ls minus ld, and then show those one at the same time. This is just going to show all those files that are having the permission 755, but they're text file. They don't need to have the executable. Similarly, if I look at the source with the C++, those are source file. Similarly with Python, so that recursive permission, don't do that one, because I just was trying to demonstrate this one, and I'm now showing you the permission that are on inaccurate. So in order to correct it, you just go here back again, say change mode, switch user, and then you become root, and then go to home wlitv, clear screen, and then from program files, notice that the program files wlitv, everything that is there, I can even do at the wlitv here level here, say find dot minus find dot slash wlitv minus name star dot c++ minus exact, and then in this case is ls minus l d, and then that file. If I just do this one, it's going to show me all the C++ code that are read-write executable. But because these are source file, if I just want to know the type of them, they are going to say these are source code of C++. So in order to correct that earlier stuff, you could just say, and these are source code. So I'm going to say change mode 644. And then that just did it. So right here, I'm going to run that command here, and then this time I run the ls command here again, and then it is perfectly fine. Similarly, if I want to do the one with the .sh for the shell, you could do that, and the similarly .bash. So anything that are shell script or text file, they need to have those permission. So text file, and that's there. And then similarly .py. So now we have the proper permission for everything. So if I just go back here and say find dot slash wlitfi minus name the star, and then say minus exact ls minus ld, and then I could just do it in one shot to just make sure that this is running fast enough. I could do that way, and then notice that it is just showing the proper information. For someone, the one that are directory, they are executable. They supposed to be with the read write execute there. The one that are regular file, it is there. And this is just a lot of information, so I'm going to Control C out of it. But we could be specific to one directory, so like for example, minus type D, and then just list that minus type. When you do minus name star, you have to say minus name star and minus type D. So now I'm going to just do kind of like more than one Boolean expression. So minus name is this, and minus type is D, and then this asterisk is meaningless here. And then we do that one, and then just run it, and that would be your find command here, and that is going to find all the files that are that are type of directories. As you can see in the first column, they're all these, and then you can see the permissions are set up properly for those directories. So clear screen here. If I just do this one, and instead of just say under wlitfi programs, this would be shorter. Obviously, there's Apache and other things. Let's just do on the programs, and then just say shells. And then that's for shells and all the scripts that are there. It was not that big. You can always just do your find command however you want to do it, and just change it to specific things. For example, loop directory. Now this is just going to be a smaller directory. Or right here, and instead of this, I could do like, let's say Python. See how big is that one? That one is not that big either. So clear the screen here, and then run that Python. Clear the screen here, and then run that with C++. And let's see if on the C++ is not that huge. So we can just say that is the directory. But if I want to not list the directory, and I want to say, show me all the files here, then I could just do something like this. I don't need to escape the left parentheses. So this would be just that. Okay. I hope you enjoyed it. I'm going to stop at this session because there's a lot of other things that I could show you and compare between Windows and Linux and other ones. But at this time, I'm going to stop this video because it's going to be too long, and people, they don't like to watch too long videos for some reason. Have a nice one. Take care. Thanks for watching. God bless you.